phones and everything. By the way, is there anybody who is like coming from outside the state or?
Yes, sir. We have some participants from Tamil Nadu, Pondicherry as well.
Okay, fine. Then I'll continue with English. Otherwise, I thought probably I'll speak some is in between. But anyway, I'll restrict to English. Okay. So now that the AI has become a synonymous with our everyday life, like if you have an iPhone 16 or 15 Pro, then you have an Apple Intelligence just at your phone. And of course, in Gemini and the Google, whenever nowadays you do a Google search, immediately suppose what is AI? If I write down in Google search window, then immediately the AI answer is coming itself. So you can see that how it is entangled. Now it is becoming very important that we also in academia, we embrace this tool. This tool is becoming like, but should not be like a black box, like we rely everything on the AI. So, but it helps immensely. So my topic is here that it's so immense and so vast that even Nobel Prize in Physics also this time awarded to Geoffrey Hinton and Hopfield. So you know that this understanding is something like, so this time this Nobel Prize is given not for invention or for application. Normally Nobel Prizes is given to inventions. So this is a little bit, outlier. So the point here is that what I'm trying to make, then it's an FTP, it's not a training session. So my job is to introduce to the whole tool. So I cannot possibly take in 1.5 hours, I cannot possibly teach you how ANN or artificial neural network works, but I will try to show you some demo and some tools, because I gathered that some of the people joining in this course are completely newcomer. I mean, newcomer to this field. So I'm taking that assumption, right? So that means people are having little bit of experience and no experience at all. So this is my presumptions. This is on this surmise I will go on. So now that you know that this ANN, or artificial intelligence for this matter, let us, if we talk about the artificial intelligence, then you can see that the artificial intelligence is, it's basically artificial intelligence as an artificial neural network, because as a human being, my intelligence depends on how my brain thinks. So in the same way, the artificial intelligence also requires a brain, and that brain is the artificial neural network. So the artificial neural network is actually what I'm going to talk about. And if we talk about the artificial neural network, then immediately, or AI for that matter, immediately it comes, to me, it's like that movie by Steven Spielberg, AI, 1997 or 1996 movie, where a person like David, that you can see that David is actually, it's a humanoid robot who is programmed to love his mother. So that's the kind of artificial intelligence. Now we are almost closer to that level, not at least that level, but at least something akin to that. So our artificial intelligence now has encompassed everything. So I just cannot resist myself from showing this David. But this is like but if you talk about the artificial intelligence backbone, the backbone, then it always comes out to be something, the network that we have in our brain, that's called neural network or neurons. So as you can see, this is an artist's impression of a neuron, and neuron is basically a cell, a very specific kind of cell. The neuron analogy I would like to give, that analogy is like a electronic gate. So you have an input and then you have an output. So you give something and the network will process and it will give an output. Now, if I take this particular analogy to neuron, then I can say that neuron is a specialized cell in our brain. There's a special cell. Our body has got a special cell, like a heart has got a cardiac muscle. They're special. They don't get fatigue. Like, for example, if a person is living 100 years, 70 or 90 years, from the moment of conception, from the moment of death, the heart muscles are pumping. So they don't get fatigue. But the same is not is true with our leg muscle. Our leg muscle tend to get fatigued. If I walk for 5 kilometers, then I tired, but my heart doesn't get tired. That means every muscle has got different kind of cells in our body. So that means neuron is a special cell in our brain where actually we have got something called dendrites, which is a nucleus and cell body. The biology people will know that there is a Golgi body and everything is like that, but it's a special cell, like a cardiac cell. So it has got a dendrites, which is like a, and then you have got a special axon terminals, and they are connected by something called axon. So, and on your left, you have got a dendrites, which is like an input. It's like a sensory organs. That means whatever input I get it from my hand, my skin, my ear, my nose, and my eyes, these are actually processed by the dendrites. Then it's basically processed, and then the output is given to the eye organs. For example, if a mosquito bites, then I tend to take my hand and involuntarily I'll just do a something like that. Okay, this is here my mosquito biting, and like that. So this is like an output. So it's like a gate. So you have an input and you have an output. And in between that, you have to process. Now, in that process, you need that, a neuron cannot work if it doesn't know beforehand. That means suppose somebody is telling that this is a bad thing, I should not eat. From my eyes, I get to know that there is something food item. Now, my experience would tell me whether this food item is good or bad. If somebody doesn't tell me that this is not bad, this is not bad for your body, then I'll try to consume. Like, for example, if there's a liquid going on, if I'm feeling thirsty, then I'll just go and drink the liquid. But if I know that this liquid is dangerous, poisonous, then I'll not. So how do I know? That means I have to be trained. My brain has to be trained properly so that I can act on it. So that means neuron has to be trained. Now, let us make a small network of that artificial neuron, which is like I will call something like a neural network, or artificial, like a neuron is a network, because our brain has got millions of neuron cells. So I will do as a neuron as a network. Now, these are the mathematical neurons. Like I have got a axon, these are like a dendrites, which are like a terminals, and this is like an output, which are like axon terminals. Okay, and I'm going to act on that. Now, if I say that I have got a sensory organ, this is my input layer, and mathematically my hands, my limbs, and whatever, my mind, my mouth, this is like my output layer, and inside my brain I have got a hidden layers of neurons, right? And then now let us now design artificial network, a very simple artificial network. Okay, so simple artificial network, if I design, then first of all, let us say that I have got a certain weights of a human being. Suppose I have got a class of 50 students, and I will have a 50 weights, like 50 kg, 60 kg, 65 kg. And then you have got a size of, let us say, shoe size, or the shirt size, or pant size, or something like size. So that means I'm relating my weight to the size. So this is my training data set. That means I have my weights and I have my given size. If I want to connect that, then I will connect with a neuron layer. So like here, I have got only two neuron cell. One is N1 and one is N2, right? These are two neuron cells. I am trying to connect these things. Now, if I connect that, then I will connect, the weight is also processed by neuron N1, and X2 number, second weight, is also processed by both the neuron N2. And both the neuron will process and they will give the size. This is a training data set. That means somebody said that you have got a 50, then 50 kg, then shoe size is 5, 60 kg, shoe size is 6. Then I know that if there is a 5.5, shoe size will be between 6 and the 5. That's like a simple logic. So I'm going to train that. Okay, so I'm going to train that. And when we'll training, then we can approximate my y as a function of fx. That means my output y, which is the size, is nothing but a mathematical function of x's. Only shortcoming is that I don't know what is the form of fx. Now that fx has to be determined by the neural network. So neural network does nothing, it just creates a function which will give the output in terms of the input in the form of a function, and my whole job is to determine that function. Okay, now all this simplicity, I can say I will give some weightage. Weightage means every neuron, every weight, I will have a mathematical weight that is called W1, W2. You can see the neuron 1 is associated with W1 weight as far as the weight X1 is concerned. Then W2 as far as the weight X2 is concerned. Then W4, it is like a weight which is like a output is concerned. W5, which is like an N2 output is concerned. What are these weights? These weights are like balancing loads in my brain. For example, if I know that if the liquid is red colored, I should not drink it. So that's like in weight, I have got my mathematical weight of my brain. So if tomorrow a liquid comes which is slightly on the orange side, then my brain will signal it is something akin to red, so please don't drink. So that's like a weight. But right now, these weights are undetermined because I don't know. These weights are undetermined. So I'll try to determine these weights. Okay, so that's what I will do. And I will write a mathematical equation. It's a simple linear mathematical equation that the value of neuron N1, whether it will switch on and switch off, depends on the weight 1, X1 plus weight 2, X2 plus B1 and B2. B1 and B2 are called bias. Bias means these are the already given weight, a kind of weight already associated with my neuron. That means, suppose some people like red color. Some people like blue color. So how do you give that? How do you justify that? That means I have got a specific weight which is more toward the red color, but you have got a specific weight in your brain which is more toward the blue color. So this is like a bias. So every neuron is not something called a bias, right? So I will write a simple equation, and I'll write the final equation, which is my Y output, which is weight 4 into N1, weight 5 into N2, and plus B3, bias of the weight itself. Okay, so that's the kind of Y. Now my job is to determine what are the weights W5 and W4, W1, W2, W3, and W4, and W4 and W5. It's my job, neural network job, is to determine these weights along with B1, B2, and B3, depending on the training set. So I will do an optimization kind of things and determine this weight and fix. Once I fix it, then I can determine the data from an unknown set. So that's what is being done. Now, if I take that, just this is Y is equal to fx. I'd like to do that, and then I would like to write down the loss function. I mean, like, I have got a training data set. That I have got a weight and a specific set. So I exactly know what number of what kg person having 50 kg, what numbers of shoe size this person wear. So that I exactly know. So that means I have got my solution Y. And I will first take an arbitrary solution from just like a trial solution. How do you solve a differential equation? You have a differential equation, let us say simple harmonic motion. I take a trial solution. Trial solution I put into the differential equation and I match with the initial conditions. Then I find out that, okay, if the initial conditions are like this, then the trial solution will be my exact solution. Got it? The same way, I take an arbitrary solution from the neural. That means I will take arbitrary value of W1, W2, W3, and W4, B1 and B2, and then try to predict the value. I got that value. That value I have denoted is by Y cap, right? And then I will take the difference between the actual value and Y cap and take the summation. That is called L2 NOR. Okay? N is my number of observation. And then I'll try to minimize. It's like a least square fitting. So least square, you do what? You find out the errors at different points and try to minimize that. So that's called minimization. Once I minimize, then I fix up my error. Then I could anything, then I'll get it. Is it okay, Partha? I am doing fine? Or is it becoming too obvious?
No, it's okay, sir. It's very nice, sir.
Okay. So I hope I'll be able to give you a sense of doing.
Yes, sir.
Other than doing how to use a ChatGPT, I'm going to the basics of the thing. What is the basics like? So this is what the optimization done. So every neural network has got an initial data, then training set, then optimization, then ultimately final. So that's what it is being done. This is known as a loss function or cost function. So your idea is to minimize this cost function. This is the This is the things. Now we are going to do a slightly more robust example and try to give it. I'm so sorry. Try to give a sense of doing like how we are going to design a neural network. Now, whatever I have told you, that I have told you on the basis of the mathematical function. But let us now try to do a little bit more on that. Okay, so let us now do I take an example, practical example. So I have got three values of the heights of a person. One is 6 feet, one is 5 feet, one is 4 feet. And then I have got a training data set that I have got a weight of the person that is 80 kg, 50 kg, 40 kg. That means this 6 feet person is of 80 kg, 5 feet person is of 50 kg, 4 feet person is of 40 kg. My job is to find out if a person has a 5.5 feet, then what will be the weight? So let us create a neural network to do that. Very basics, okay? So the question is that how will I know? Now, first of all, I'll try to correlate the 6 feet with the 50 and 40 kg also, because there might be exception that person is 6 feet high, but the person might have a 50 kg, or person might have a 40 kg, very lean and thin. A person which is might having a 50 kg, but it might have 80 kg, very obese, or maybe 40 kg. So I need to connect those relations also, because there may be exception into my data sets. Now the question is that how do I do that? So how do I fix the mathematical weights now? The mathematical weight that you have already seen, this weight have to be fixed. So how do I fix those mathematical weights? Okay, now I will take a guess. I will take something. Let us now take a weight value initial, because I have to start with something. Remember, your trial solution, you have to start with something. That trial solution, you have to guess intelligently. Suppose you have a simple harmonic equation, then you have to guess your trial solution based on the simple harmonic oscillations, right? So that you can do. So here I will try to take a variable which is the weight per height. That means I will take the weight by height as a ratio as a starting value. So you can see that this is 13.3, 80 kg by 6 feet, 50 by 10, that is 5, 40 by 10, that is 4. Now I will do a mathematical activation function. I will design an activation function, but these activation functions, somebody is drawing something right now. Okay. So I'm doing an activation function. That activation function.
Sir, I have muted everyone, sir. Kindly on your speaker, sir. I have muted all the participants. Kindly on your speaker, because there was some disturbance.
Okay, fine. So now the question is that I have got a particular weight, particular distance. I have taken the weight by height to be initial value, and then I'll try to do some kind of function, some kind of activation function. Now this activation function, for this example, I will take it to average weight by height. That means I will just add these three things together, and then I'll make a 11.1. I don't know why that red color is coming. Leave it. Okay. So that 11.1 is the average, average weight per height. Now I will take this as an activation function. This is my activation function. And now I immediately know what is a 5.5% will be. And 5.5 feet persons, it will go, if I weight it, multiply, it will be 61.1 kg. And that will be actually practically, it's like a that's a kind of almost accurate kind of things. So now you know that what I have done. I have got a training data set. I have fixed my weights bias, that means mathematical weights. And then I have done an activation function. In this particular case, this activation function is my average. But you can choose your activation function. Now, you know that if you remember that physics Nobel Prize was given to Geoffrey Hinton and Hopfield, their main idea was to design that activation function. The activation function they have designed based on probability, which is why they have got a Nobel Prize. So activation function is what they have got the Nobel Prize for. I mean, how do you design an activation function? Depends on the probability, because our decisions are always probabilistic. human mind decision, artificial intelligence is always probabilistic. If you say today I might like chicken and tomorrow I might not even like it. Today I like rice, tomorrow I might like even roti. Today I might like the red color, tomorrow I don't even like the red color. So they may not be, like extreme logic. We function as a non-deterministic system, because our decision might vary from situation to situation depending on very many factors. Okay, so that's why you need a probability. So I'll have to design a probabilistic activation function and then minimize, and that's why this Geoffrey Hinton and Hopfield has got this Nobel Prize. So this is the basics of the whole thing. And now let us go back to ANN flowchart, like how I'm going to do an artificial neural network modeling. What is the flowchart? The flowchart, if I go, then you can see that this flowchart is, let us look at it here. First of all, you have to consolidate your data set, because you have to have a training data set. Before you take a decision, I need to know what I need to have an experience. Otherwise, I cannot. So if you ask me what is Maxwell's equation, for example, I'll have to know electrodynamics. Without knowing electrodynamics, I cannot tell you what is Maxwell's equation. I cannot do your imaginary number if I don't even know the number chart. So that means I have to have a training data sets. So you have a training data sets, then you fix your neuron. One input is a must, then output is a must. You may not have any neuron in between. That means it is like a not thinking anything. I have just taken something on my hand and directly I do that things output. So you are supposed to give some hidden layers. In hidden layers, you give a neuron, then choose your activation function. That activation function is a probabilistic activation function. There are many activation functions. One is 10 hyperbolic ReLU, or whatever you call like an activation function. I'm not going to go into details of that, but then choose your optimization. How you will optimize the data? You have got a trial solution, you have got a real solution. You have to optimize your weights, so like a least square fitting. So you have to optimize your weights, and once your optimization is done, then you can use your test data set to test whether you are on the right track or not, right? So now I'm going up to ANN tools. What are the basic tools that you require to do an artificial intelligence programming? I'm not going to artificial intelligence much more than that. I'm going to the basics of artificial intelligence, which is artificial neural network, because every artificial intelligence system has got a neural network inside them. Just like I have got a brain, every person has got a brain inside the intelligence. So that's why I need the ANN. Now, what are the tools? Now, if I go to the tools, I'll be very general. If you talk about the tools, then you have this, first of all, comes to my mind is Google Colab. Now, Google Colab, I'm going to give a little bit demo also afterward. Like Colab is called Collaborative Research. It's a Google Colab. First of all, the Google Colab is completely free. It's free. This is you can, if you have a Google account, you can just sign to colab.google.com and immediately you get that welcome screen. So this is free. First of all, this is free. This was the first thing, that you don't have to pay any money. Only you can be run from any modern browser. Chrome just need internet connectivity. You need a modest internet connectivity. You don't even high speed. Your 4G network will be done, because everything will be processed by Google server. You only need the interface. Any modest modern browsers, that will do. Okay. Then of course, it always kept updated. You don't have to update any system, because Google is always up to date. They are always updating your software, so you don't have to bother about that. And you can do even research level job in Colab. The first numeric ANN paper that we have published actually on the Google Colab. We didn't run anything in our computer. Everything is Google Colab. Now, what are the tools? The first of all, why I have given you to Colab, because you don't need to set up anything on your laptop or computer. You just have to go to Google colab.research.com and immediately you are set up. You are all set. Okay, you can just run the first numerical network, or neural network programming. So what are the tools? I hope that everybody is familiar nowadays to computer programming. And one of the tool that is essential for artificial neural network is Python. Unless, of course, you want to do by programming from the very basics. Nobody want to reinvent the wheel. So you want the You want a working environment where you can do the meaningful work. So it is better to learn Python, because Python is the tool for beginners with artificial neural network. Then of course you've got other like R, Julia, there are many other things, but Python is basics. Everybody need to understand Python. So if you do a Python, then the very first package, many of you are familiar to that, that's called NumPy. So NumPy means numerical Python. So NumPy, what is NumPy? The NumPy NumPy is a huge amount of useful mathematical function. For example, sine, cos, log, hypergeometric function, all this kind of things, tan hyperbolic, log, of the cos hyperbolic, everything it has got, random number generations. Then it can support large format arrays with hundreds, thousands of numbers. I mean, several degrees of arrays, like 3-dimension, 4-dimension, all kind of n-dimensional arrays. Then it has got a lot of array manipulation techniques. You can manipulate the array like, it's very easy. It becomes very easy. Then, of course, you can do many scientific manipulation as well. For example, if I want to do, I'm not going to give an example here, but you can do a lot of scientific manipulation. So this is an essential tool that you require for ANN simulation. Then, of course, the next thing we are coming is the pandas. Now, pandas actually is again a data. It's a kind of tools. Those are freely available in Google Colab. It's a data manipulation and analysis package that run on the top of the Python. Okay, in Colab you can have everything. The name is derived from the panel data. That means panda panel data, and it can transform and summarize data in a very clever way. I will see some of the examples. Okay, then it can provide information and describe large data sets. Suppose I have got thousands of data sets about suppose heart patient. Then what information I can get it from there? So that's like it. Then one of the very essential that I found is that Scikit learning. So that's like it's a scientific kit. Actually, it's a learning. This is also a data manipulation software. I mean, like it's all written on Python. You can actually work it on that. It's a machine learning library. It has got many essential tools which we require for ANN research or doing our job in using artificial neural network. Then, of course, it can classify, do regression, and a lot more. Then, of course, one of the very basic mathematical tool for plotting, plotting software is a Matplotlib. So Matplotlib is essential. This is like you require that every day. It's like a very plotting, scatter plotting, 3D plotting, 2D plotting, fitting. It requires a plotting library. So because visualization is all about, so Matplotlib is a plotting library which you require, and that is very essential. The basic plotting library which you need everywhere. And then the neural engine is coming. That means you need an engine. We call it engine. The neural engine, which actually doing all these neural network calculations. You don't have to invent the wheel. We are not doing research on artificial neural network. My job is to tell you how you can utilize the tools to do your own problem, right? So here we are talking about the very basic that is called TensorFlow. So TensorFlow is actually developed by Google. It's one of the finest neural network engine or library. It's actually, and it's so complex that you need an API interface to work on that. That is called API or, the performing toolkit, right? Application performance interface, API. So it's like a guy, like, I need some kind of operating system to talk to my computer. So similarly, in order to talk to TensorFlow, you need some kind of wrapper, some kind of API, some kind of a kind of guy-like things. And TensorFlow is the main neural engine, that ANN processing engine that you require. It does all these things. All these things before the TensorFlow, these are manipulate data, because data sometimes comes in many formats. You have to correct it. You will have to actually correct the data. For example, some data might have got empty rows. You'll have to find out those empty rows, otherwise it will give errors. Some data might be already correlated. That means I have got, suppose correlation, that means data are similar. So you can toss away some of the data. So you don't require the correlated data. That means if two columns, suppose we have got a 20 column data set, and two columns of data are very similar to each other, they've got a finite correlation of the order of 0.8 or 0.9, then you can actually remove one of the data set because this is like not needed. So all this cleaning you'll have to do before you apply the data set to TensorFlow. That means neural network. And it's a main engine. TF will provide you the facility to add input, output, and hidden neuron layer, activation function, optimization option, and many more required for full ANN analysis. So TensorFlow, then we talk about API, like what wrapper, what API I will need to talk to, because talking to the TensorFlow directly becoming very difficult because it's like a very involved. So you need some tools to do that. That is called Keras. Okay, this is a standard. Keras is a wrapper. It's like a operating system working so that through which you can actually work, you can talk to TensorFlow, which will take your data and process this neural network analysis. Okay, so the Keras is the main API for TensorFlow. Okay, now it's time to take a little demo. Okay, because it's already 12:30. I think half an hour is gone. So I will take a little demo of around half an hour. The next half an hour, we will go about the application. So I will stop sharing at this moment. Sorry. This is an application, of course. So I will stop sharing and I'll share my whole screen. Is it okay?
Yes, sir. Yes, sir.
Yeah, I'll share my whole desktop. Okay. So that's my whole desktop. Probably you are seeing it. Are you seeing my whole desktop?
Yes, sir.
Yes,
Yeah.
sir.
So you can see that. Well, let me do a complete desktop. Maybe I will. Now it is visible, quite visible?
Yeah, now it's visible, sir. Now
Yes.
it's visible.
Okay. So you see, I have got a data set, which is like a, heart disease, suppose. And this I call as a heart.csv. Okay. So let us see the data set itself. So this is like a, let me, like a data set. So this is like a data set. You can see the data set. So it's like it's a simple data. It's like an A's. You can see that one side this is A's, one side 1 or 0. 1, 0 means either female or male. Okay, because we are not working the transgender right now. So this is a simple data set. So the data set is actually having around 300 something data. I can see the data set. It's around 304 data number. So 304 person heart, 303 persons heart monitoring parameters. So one is the sex, that is either 1 or 0. So 1 you can take it as a female, 0 you can take it as a male, or 0 you can take it. It doesn't matter. These are just a 0 and 1. Then you have got some like BP blood pressure number, 145, 130. This is the resting blood pressure. When you just sleep, then what is the blood pressure? Because when I work, the blood pressure is definitely higher. So normally we know that our blood pressure is around 120. It should be, but some people have a lot higher, 145, 13, like that, Then cholesterol, then you forget about that. These are data. Okay, these are all data like a cholesterol, then something, thalassemia, whether you have a thalassemia or like that. So forget about that. That's not actually essential. So you have got a data set. Now this data set, I will like to import. The data set lies on my computer. So now I'm in Google Colab. So what I'll do, first of all, I will upload my data set. So this is the upload. So that I upload my data set. So my data set is somewhere lying in my download folder. The download folder, I have got some hard.csv somewhere, maybe. Yeah, hard.csv. So I'll upload this data set. So it just gives a warning. It says that this data set will be for this time only. That means tomorrow, if I again log in, then I'll have to again reload the data. So you can just ignore that. So data set is now here. Now I can, as you can see, I'm using pandas. Okay. So I'll import the pandas, I'll read the data set, and I'll ask Panda to summarize my data sets, right? Ask Panda to summarize my data set. So it says age is 63, sex is this, CP, this, all these things it has given. I can also use Panda to give the information. So you can see it gives information so that human being can read it. It says it has got a 303 entries. It says all the columns are like this. These are the column heading. These are the data. And data type is integer 64. Integer 64 means it's an integer number. Float 64 is like a floating number. So this is like a summarize. Then I will do a, I'll not do a correlation survey here. Of course, I'll try to just, I'm not going to do a, like, all these things. So now I have got a data set. First of all, what I will do, this is for a very basic. I have got a data set. This is actually a training data set. Now, in the training data set itself, I will divide half of the data set as my training, other half I will act as a target. Do you understand that, right? Because that means I'm using my training data set, and half of the data set I use to train my neural network, and then I'll try to predict the rest of the half of the data sets by using my network, and I will show what is my correlation coefficient. That means how much I have been successful. So these are the actually commands. So you don't need to know that. When you read a real book or take a lesson, then you will immediately know these are the something that I am segregating my data sets from target, and Y is my target, X is my input value. Okay, and then data frame describe. So now I will say describe my data frame. You can see that it has given me describe what is the mean of the data, what is the standard deviation of data, what's the minimum of the data, what's the maximum of the data for column wise. For example, this column is actually my age. So what is the minimum age? Minimum age is 29 years, maximum age is 77. The median is 54, and standard deviation is 9.8. Similarly, if I can see that what are my data set of sex, like I can see that this is maximum is 1, minimum is 0, because either it will have to be male or female. Similarly, you can go on cholesterol, blood pressure. You can see that everything you can do on that way. Blood pressure, for example, minimum blood pressure I've got is 94, maximum blood pressure is 200, and median is somewhere in between 131. And then of course I have got a history of all the data. Then I'm using even scikit-learn. So it says, remember, this is a machine learning library. So you don't have to know all the comments, but I'm saying that I have to process the data through the scikit-learn. And then I will do a value counts, whatever it is, it doesn't. Now I am using sklearning, scikit-learn for model selection. So model selection I will do a model selection. You don't have to do, I'm not giving a training. I'm just giving you what are the steps involved. That means so far, I have only done the data cleaning. Suppose some data are negative. By mistake, it can happen. Some blood pressure numbers are maybe negative. So then what you do? You have to remove this data, right? So all the cleaning have to be done before you put the data into your neural network. So that means you are training now. Now I will import TensorFlow Keras as a TF. That's my main neural engine. So that is what I'm importing. Everything I'm doing Google Colab. It will take some time. It has imported. Now, of course, I can Panda. I'm still using Panda to say how many columns I have. I've got a 13 columns. And then here I can see that I have used my model. So I'm using sequential model. And then you can read. I'm using hidden layer 16, dense layer 32, output layer 1. Because I need only one layer output, because I need either 0 or whether the person will be having a heart attack or not. It's like that, okay? So, and I can see activation, I'm using ReLU. So every layer to layer, you'll have to use activation function. Like how your input layer to first hidden layer, you do an ReLU activation. Then first hidden layer to second hidden layer, you have got again ReLU activation. Then the output layer to the final hidden layer to output layer, you are doing a sigmoid function. That sigmoid function is what actually designed by Geoffrey Hinton, and for which, and this sigmoid function was based on Boltzmann's statistics, thermodynamical statistics, probability function, Maxwell's Boltzmann statistics, which is why he has got a Nobel Prize. So physics is hidden there. So sigmoid function is what the Geoffrey Hinton has got the Nobel Prize, designing that, applying that. And then, of course, I'm going to optimizer. Now, what is it? You know, when you optimize something, you have got a certain algorithm. Now, this is called Adams algorithm. Adams algorithm is the most widely used algorithm for minimization technique. You can think it as a nonlinear regression analysis, like a what is known as this fitting, straight line fitting. What is this? Least square fitting. The least square fitting is a linear regression model. It's a linear optimizer. Adams is a non-linear optimizer. There are so many optimizers you can have, but Adams, you can use it. Now, once I use that things, all my ANN is fixed. You don't have to actually do a neural network programming. All you have to do is a TensorFlow. So see, I have described my model, which is sequential. That means from input layer, first hidden layer will take, second hidden layer, first hidden layer to second hidden layer will take, then from third hidden layer, it will take the output layer. That's called sequential. Sometimes you might have a different communication. That is called parallel. So I'm using the very simple sequential model. I'm using a dense output layer that is 16, 32 neuron, and then one neuron at the output level. And then Adams and matrix's accuracy. So I'll just execute that. My model is built. You can see the model is built within seconds, fraction of a second. Now, of course, I'll have to fit my model. Now, this is the training part. So I'm running my neural network. It will, epoch means time step. That means 500 time steps I will run. Every time step I will run 1. So 1, 2, 3, 4, it will go up till 500. So let us run it. So it is running. It's running. You can see that it's going 40, 55, 60, until 500 it will go. Okay. 149, 65, 72, 500 it will keep on learning. Now it is training the data set. It is now fixing all the weights and bases, optimizing all the weights and bases, weights and bias and whatever I have introduced. I mean, those are now being fixed up by the neural network by optimization and the activation function. Activation function optimization, like the hit and one every time it is going hit and trial, and 500 it is down. So my accuracy is almost 1%, loss is 0.000119. So that means it's quite good. Now, of course, I'll have to test it. Okay, now model evaluate. Let us say, now I am evaluating model, and then accuracy is 8.8496. So my accuracy of the model is around 84%, which is not bad. So that means if I now give an unknown data set, it will be able to immediately give me whether this person will be able to have a heart attack or not. Understood? So this is like a very, there are many other things that we can do, but I'm not going to details. And now I am coming back to, I'm stopping sharing these things, and I will just go back to my presentation. This is what, let me now, where is my presentation? Let me show that in screen sharing. My submitting. Right. Okay. I will stop. I will now again share my screen, my my window. Where is my keynote? That's right. So you can see, right? You have seen what I have done, right? So that means my point here is to show you that you don't need a rocket science to do these things. If you have a data set, many of you might have a data set, remote sensing data set, biological data set, and the greatest capability of a neural network is to relate the data set from one data set to another data set. For example, let me give a practical example. Suppose I have got a data set of Zoha rice cultivated in Assam, let us say in Golaghat district, for last 50 years, and I have the data of carbohydrate, average carbohydrate that Zoha Saul has, which are cultivated in Golaghat over last 50 years. This is a hypothetical data set where your college is located. Okay, so assume that I have got the data set that amount of carbohydrate, percentage of carbohydrate contained by Zoha rice cultivated in the particular area that is Golaghat during last 50 years. I also have a data set which is giving the average ambient temperature in the cultivating season for last 50 years. Now, if I tell you that what is the relation between these two, I don't think it is possible to do anything by looking at the data sets. It's not possible. It's simply not possible because the huge data, how do I know what is that? How it is related to that? Or if at all there is a connection, there may not be any connection. I mean, the amount of, the climate change might affect the yield of Zoha rice. It may not affect the carbohydrate percentage. So there may not be any relation, or there may be a relation which I don't know. Now, the greatest efficacy of neural network or artificial intelligence is if there is a relation between these two apparently different data sets, then it will find one. So that's what its greatest efficacy. That means if there's a relation, then it will find. By optimizing all those bases and all the biases and weights, it can find if there is any relation. So if there is a relation, you exist, that means the correlation value that you can see that we have already given the 0.84%. That means 84% the neural network is sure about whether the person having heart attack or not, it can determine. So if these two data sets have a correlation value of some neural network, if I analyze this one neural network, if I find there is a 90% relation, which is not obvious by looking at, then I know that the climate change is affecting the percentage of carbohydrate in a particular rice species cultivated in a particular area. And this can give you a more insight of how to cultivate it more, how to apply different manure, different these things, water, and all kinds of things. So now you can imagine that what other data you can take. This is a very rich field. Okay, so that's why now that you know what I'm doing, that I have got an input layer, I've got an output layer, I mix up activation function, I have done optimization, then I have got these things. Now I'm going to take it to another level now. That is called physics-inspired neural network. Okay, so I'll have around 40 minutes. I'll stop it within time. Okay, so let us now talk about this PIN, or physics-inspired neural network. So this is just the screen. You don't have to understand everything. So what this PIN is doing, let us now talk about the PIN. Applying the neural network very cleverly to solve the differential equations. Now, why do you need this? You can ask me that you have a differential equation, you can solve it by any means. But hold it. Differential equation, when you have a huge number of differential equations, then it's very difficult to solve completely. Now, the question here is that why do you need differential equation? You remember, if you're a student of physics or science, then you know that every physical model that we build, they are actually built on differential equation. Think about the atmosphere. For atmosphere, I have got n numbers of differential equation. One for atmosphere albedo, one for the humidity, one for temperature, one for wind, one for rain. I have got all these different numerical differential equations. Now, this differential equation I can solve. But the question here comes, how do I use the neural network to solve differential equation? And it comes with an added advantage that I will show you afterwards. So let us now assume that I have got a differential equation. Now you know the basic things of neural network, right? Now consider this is a very simple second order differential equation with A, B, C, D constants, and you have got a d2y, dy, dx, and y. This is the differential equation that every day you find in physics textbooks. Okay, it can be modeled to simple harmonic oscillator equation, Newton's second law, whatnot. Now, with the initial condition that the y is equal to alpha, y prime is equal to beta. because it has got a second order differential equations, you have got a two initial condition, one for y and one for y prime. That is a one for y and one for dy dx. So that's the initial condition alpha and beta, which are known. Now I will write that equation in a slightly different way. I will say that the solution of the differential equation, let us model it through a numeric neural network. That means this is my x, this is my y, x is my input function, that is the initial value, neural network is my neural network, and y is my output value. Now let us assume that I am approximating the solution of the differential equation with a neural network which is curly n. Actual values are y hat. Y hat is the actual solution, but I am approximating a neural network that is called nx. Okay, then what I will get? I will write my differential equation in such a way. Okay, like that. So what I did, I take my original equation, which I have written slightly differently. I have written d was on the right hand side. I transformed into the left hand side. Now you know that this differential equation satisfied by the initial condition, alpha and beta. That means if I put alpha and beta, then I should have a L. L should be 0. Because the differential equation is satisfied by the initial condition. That means this L I can take as a loss function from my neural network, and then I put it on a neural network and I minimize this loss, and as a result I have got a differential equation solver. Now as an example, I will show you how we have used this technique of solving differential equation in the neural network, and we have applied to the pandemic, that is COVID pandemic, and we have in fact published a paper on that. Okay, let us show that what we have done. So I'm just modeling a pandemic. Now what is a model of a pandemic? The pandemic, you know, if you write the pandemic, it's like epidemiology. If you write the epidemiology, then actually you have a model. The model is like, these are like susceptible population. This is like a rich. These are susceptible population. This is the exposed population, the population which is exposed to the virus. Then these are infected population. Like not all of the exposed population become infected. So you have a certain number of population infected. And these infected people, how do I know these infected people? We know that because this has been reported in the hospitals or governmental database. They know that, okay, Golaghat has got this much of infected populations. But there are people which has got COVID but never reported. They stayed put in their house and never reported to outside. But it doesn't mean that they are not affecting the population. They are affecting the population, but government do not know about their existence. So these are called undetected population. Okay, our job was to find out, it's a curious actually, our job was to find out what is the ratio of undetected versus detected population in the state-wise in the Indian country. Because in India, not every people reported, and data keeping is not very good. For example, we don't know, for example, how many COVID patients are there in GMC or Guwahati Medical College, which are in critical condition, which are not in critical condition. In Italy, for example, they have got a meticulous data. I mean, if you go to a hospital, you immediately know that this percentage of people are requiring oxygen, this number of people are having in ventilator support, this number of people are having past disease, and all the data are there, and then you can model it very accurately. But in a country like India, it is not very easy. I can only say, okay, around, suppose today 50% are infected with COVID, but I don't know how many people are in ventilator, how many people are having serious condition, how many people are not having serious condition. So under that case, we have said that our job is to determine how many people have hidden their disease. They have not reported to the public. So that's like the model. This model then, depending on the different rates of infection, incubation period, you can write a differential equation based on this model. And these differential equations are like this differential equation. One for susceptible, one for infected, one for undetected, one for one for exposed, one for infected, one for R, that is died, removed population. So S is the susceptible population, that means you and me, which can catch the disease. One is the exposed, that means I am being exposed to COVID virus. You have not been exposed to COVID virus. U means undetected. I had got COVID. I didn't report to the hospital. I stayed quiet in my home, but I am equally infectious, and you have reported your disease. So I am undetected. Infected means ultimately how many people are really detected by government, because infections are no. In this differential equation, you can see there are several parameters like psi t, beta t, rho t, all these things I don't know. These are like a weights and biases. I want to put these things in a neural network and determine these coefficients. That's why this is called a parameter discovery. That means you know that you've got a certain term in a differential equation which has got a certain value, but I don't know the value. You can use your PIN or physics-inspired neural network to determine that parameter. This is called parameter discovery. Okay, this is another way, another facet of, another phase of artificial neural network. Right? Now, I'm not going to do the details. I'll just show you the results, what we have got. The results are quite surprising, as well as the results are quite innovative. And so I have sold it Google Colab. You are using Cyan. Cyan is a package which actually use PIN formulation, the TensorFlow Keras wrapper. We have done it. Then these are our parameters. We have taken a parameters that's like a hidden layers, 8 hidden layers. That means output, input, output, then in between there are 8 hidden layers. Every layer has got a 64 neurons. Input layer has got a 64 neurons. Output, those are 8, 9, 10. So 10 layers and 8 hidden layers, total neurons is 512. So 512 neurons are doing the calculations. One input, one output, and 8 hidden layers. And then activation function, we have used the 10 probably. You can use any other activation function also, which you have to train your data set, like where the accuracy is more. Okay, then optimization, of course, we have used Adams, like how to linear regression analysis. And now let us present the results. The results are like, I'll show you. So what we have done, we have basically, okay. Now you can see that this is the number of days and number of infected people. Days starting from sometime in April. India, the first case was detected sometimes in April. That was 0 day and then 1 year. So these data are actually only up to this much. Only up to this much the real data. I mean, when we trained the model, we were only up till this. This is the real data. Afterward, we came to know, but this is our model. This is the PIN model, which has predicted the data up till 350 days. So you can see the accuracy of the model. This is already published, and you can see that Nonlinear Dynamics 2024. And what we have said, that how do you know that our model is correct? These are the observed, which are blue. These are the predicted. Now you can see most of the cases, our model predicts the right results. These are known results. Our model predicted it right, except for this case, which is, this case, which is like a quite high, the difference in this case as well as in this case. So out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like only 3 cases of which are outliers. Otherwise, we have been able to predict the real result, which our ANN result, quite accurately. On the basis of this, now we are going to now have this, what is known as our result of undetected population. The result is quite surprising. So you can say that we have got phase 1. India has COVID, India in 2 phases. One phase started early in April 2019, February, March, April. It went up till August. Then suddenly it seems to be as if we have recovered. Then again, these things came, the second wave, when the mortality rate was very high. Delhi, you can see all those things like that. So this we call phase 1 and phase 2. Now this shows you that the number of ratio of undetected versus detected. So in ratio of undetected versus detected in phase 1 was quite high. That means many people hidden their disease in the first phase. I had got COVID, I'll not tell you. I am just staying quiet because they didn't know the seriousness of that. When the second phase came, people realized, no, I cannot stay indoors. I'll have to report. That's why you can see that the ratio has decreased. So this is the result of artificial neural network applied to COVID pandemic. Very recent, only this year, January, we have published this paper. And this is actually using Google Colab, TensorFlow Keras, and PIN, physics-inspired neural network. Okay, so that's it. I still have around 20 minutes to go, but we can discuss. Okay, I have given a little demo, and then I have told you about how does it work. It is not rocket science. You yourself can do it using your own laptop. All you have to do is get a little course going on. There are many courses which you can sign up to learn the basic things, because course is essential, because then you know how to proceed. Research you can do on your own, but you'll have to learn the basic tricks. For example, how to use scikit-learning, how to use pandas, how to clean your data, because data cleaning is a very essential requirement. Your data might have errors. You'll be able to detect the error previously before putting it blindly into the ANN network, right? So that's why you can sign up a free course, you can sign up a paid course. You only have to provide around few thousand, like 1 to 2,000 or 3,000 rupees, maybe 1 week course. It will be very essential. I advise everybody who is not into active ANN, because this is artificial intelligence, you are not into active ANN programming, should sign up and do some course, and then you can do your own things, right? So at the last, I will give the credits. Thank you. And that's all. So I think this is my last slide. So that's it for my side. Now this is open for discussion, or if you have any kind of query, I'll be happy to tell you.
Okay, so thank you very much, sir, for your nice presentation. We actually learned lots of things from your presentation. Now, actually, it is open for discussion. So participants, if you have any questions, then you can ask, sir.
Yes. This class was not meant for teaching. This
yes,
is
sir.
Like an eye-opener, what you can do and what you should do. So
yes, sir.
You can also use the chat box if you're shy of raising your voice.
Sir, one of my colleague, actually his net connection is not good. He just conveyed me a question. He said the numerical part of the differential equation is okay, but like artificial intelligence these days, how can they solve analytically also? Suppose you put some differential equation, we can also get answer in analytical form. So he was curious about that question, sir.
Yeah, I mean, you can try. You can see. I don't have any direct answer to that. You can try putting in internet, okay, Chat GPT or something to solve this analytic equation. I mean, like you can do that. I am not nearly accustomed to, because I don't. I mean, like I believe that you have to know beforehand something. Like you can use Mathematica for that. Mathematica can analytically solve if the equation is solvable. If Mathematica cannot solve it, then artificial intelligence cannot solve it. That's because artificial intelligence, whatever available in the internet, is actually gathering data from the internet, giving you something. If you ask ChatGPT that give me, prepare a presentation of 5 slides on the Ayurveda in modern medicine, ChatGPT will do it in 5 seconds. But where it has got the data? The data it has got from the internet. It is basically only collecting the data on your behalf very intelligently and giving you the summary. But the research you have to do on your own. So if you have any differential equation, and if you don't know the answer, and if you think a black box will tell you everything, that's not the case. Okay, you use Mathematica to solve it analytically. If Mathematica cannot solve it, then of course ChatGPT or other things cannot solve. Mathematica is the gold standard for analytical solving of differential equations. That you can do. I mean, like, of course, I am not aware of any artificial intelligence toolbox which can straightforward give you answers. Google Colab can do it. I mean, Google Colab has got a Gemini interpose inbuilt. I mean, even if you do a Google Colab, for example, you can see in Google Colab, if I can, you can already see that program with an artificial intelligence is already given. So you can use Google Colab to write down a differential equation and ask the Gemini interface to solve it analytically. Yeah, anything else?
Sir, one question in chat box, actually that Alpana Borua, she asked that, is there anyone AI who can identify the error in statics research?
What research?
Statics research, sir.
Statics means what? What do you mean by static? I have to understand the equation first. What is static research?
Is there any AI who can identify the error in statistics research?
But what kind of research? You have to be Alpana. You will have to be little bit specific.
Yeah.
If you use the AI as a black box, then it will not help you. You will have to be, see, in order to get a correct answer, you also need to ask a correct question.
Yes.
I mean, error in statistics, what kind of research? Are you doing regression analysis? Are you minimizing? Are you maximizing? Are you fitting? Are you curve fitting? Are you doing some median analysis, or what is?
Sir, I'm making Alpana as co-host. She can directly talk to you. Alpana, are you there?
She can unmute. I mean, you can unmute all these things.
Oh.
Hello.
Yes.
Yeah, yes.
Sir, good afternoon, sir.
Yeah, good afternoon. Yeah, tell me.
Sir, মোৰ মানে মেছেজটো আধা হৈ থাকিলে মই আকৌ পিছত লিখিছো।
আপনি কক নাই এতিয়া মোক কলে হ'ল।
Sir, মানে আমি statisticsবোৰ যে কৰো socio-economical researchবোৰ basically I am from background of commerce. So in that research, if I am doing some of the data sheet research, in that research, if some of error happen in my statistics, that there any kind of AI tool who can identify that.
মই এটুকে আপোনাক কৈছো, আপুনি এটা ষ্টেটিষ্টিক্সৰ এটা ৰিচাৰ্চ কৰিব, এটা ডেটা আপুনি কি কৰিব মোক সেইটো জানিব লাগিব না। ডেটাটো ৰিচাৰ্চ কৰো বুলি ক'লে নহব না। এতিয়া ষ্টেটিষ্টিক্সৰ ডাটাখিনি আপুনি কি কৰিব, সেইখিনি ডাটাখিনি লৈ পেলাই আপুনি কিবাটো কৰিব লাগিব না। মই ডাটা এতিয়া আপুনি যদি কয় মোক যে, মই আপোনাক চিম্পল এক্সাম্পল দিছো, আপুনি মোক কয় যে মই আপোনাক চাউল দিছো, দাইল দিছো, চব্জি দিছো, আপুনি এটা বনাওক, মই কি বনাম মোক ক'ব লাগিব ন যে এইটো বস্তুকে, এইটো ৰিচাৰ্চটো আপুনি, there are hundreds of different data analysis or research socio-economic কি দিটা আপুনি এটা মোক এক্সাম্পল দিয়ক যে মোৰ এইটো ডেটা সেট আছে, মই এইটো ডিটাৰমাইন কৰিব বিচাৰিছো। For example, suppose you have got a data set containing the earning of people versus spending. Now you know how the cost of living, how your cost of living is affecting the spending trend. It can be like that. Okay, now if this is the things, then you can find it. Now when you talk about the error in data sets, then you don't need artificial neural network. You can need the data cleaning software. Like, somewhere you have got a minus data, somewhere you've got a something data, then you can do that. So, specific answers I'll be able to give you specific answer only when you provide specific examples. As a whole, AI cannot do everything and give you an answer out of the blue. I mean, that is my understanding, of course.
Okay, sir, মই হেতুৱে জানিব খুজিছিলো যে AI গুটেইবোৰ দিব পাৰে জানো, নোৱাৰা নিচিনাটো কিছুমান লাগে।
তেতিয়াহ'লে আমাৰ দৰকাৰ নাই, তেতিয়াহ'লে আমি কৰিবই নালাগে, তেতিয়াহ'লে আৰু গুটেইবোৰ AI দি দিলে হ'ল, তেতিয়াহ'লে আমি কি কৰিম, তেতিয়া আমিতো টিচাৰৰ কোনো দৰকাৰে নাই। এটা ডাটা লৈ পেলাই ঢালি দিলে হ'ল, বাকচত ভৰাই দিলে হ'ল যে AI প্লিজ ডু দ্যাট। এনেকুৱাটো নহয়, এনেকুৱা হ'ব নোৱাৰে, এতিয়ালৈকে এটলিষ্ট সেইটো ষ্টেজত অহা নাই। তেতিয়াহ'লেতো আমাৰ সাহিত্য লিখিবলৈও আমাক মানুহ নালাগে, AI লিখি দিব। মোক এখন ভাল অসমীয়া উপন্যাস লিখি দিয়া, মই পাব্লিছ কৰিম, AI লিখি দিব মোক আধা ঘণ্টাত। গতিকে সেইটোতো আৰু ডেফিনেটলি হ'ব নোৱাৰে। So that's
কেতিয়াবা ষ্টুডেণ্টে সুধি দিয়ে যে অমুক ছফটৱেৰ আছে, তেতিয়া আমিও ইমান ভাষ্ট নলেজ এতিয়ালৈকে নাজানো, সেইকাৰণে
আপুনি এতিয়া কয় যে ডেটাত মোৰ এৰৰ আছে, মোৰ সাপোজ আপোনাৰ এটা ষ্টেটিষ্টিকেল ডেটা আছে, ডেটাটোত আপুনি ভাবিব লাগে যে ইয়াত কিবা এটা এৰৰ আছে, তেতিয়াহ'লে ডেফিনেটলি there are tools to do that. You can actually use different tools to detect the error in the data. Suppose you have got a suppose আপোনাৰ মই লাগৰ এক্সাম্পল লৈছো যে মানুহৰ মান্থলি চেলাৰী এটা ডেটাবেছ আছে, তাত মান্থলি চেলাৰী আছে, তাত স্পেণ্ডিং ট্ৰেণ্ড আছে, তাত আপোনাৰ ফুড হোটেলত মানুহজন মাহেকত কিমান যায় তাৰ আপোনাৰ ডেটা আছে, তেওঁ এমাজনৰ পৰা কিমান বস্তু কিনে তাৰ ডেটা আছে, সাপোজ এইটো ডেটা আছে। এতিয়া তাৰ ডেটাৰ ভিতৰত তাৰে ধৰ আৰু এটা ডেটা আছে মানুহজনৰ, সাপোজ তেওঁ হেল্থটো কেনেকুৱা, BMI বডি মাছ ইণ্ডেক্স, সেইটো এটা ডেটা আছে। এতিয়া ডাইৰেক্টলি আপুনি ক'ব পাৰে যে তেওঁৰ আৰ্নিং টু বডি মাছ ইণ্ডেক্সৰ লগত ৰিলেটেড নহ'ব পাৰে, that may not be related, right? বডি মাছ ইণ্ডেক্স আৰু আৰ্নিংছ। এতিয়া কিন্তু ধৰক তেওঁৰ যিটো মান্থলি চেলাৰী, it might be directly proportional to this person spending in Amazon website. Now these two data sets might be acting completely similarly. Now if you, I have shown you the tools like pandas. Now pandas can find out whether there is any correlation between this data set. What's the correlation? Correlation is that whether the data sets are similar to each other. So a correlation of 1 means that they're exactly same. And correlation around 0.8 or 0.9 or 0.75, more than 0.8, you can, if your correlation is more than 0.8, then you can think that these data sets are similar. So one data set not necessary, I can toss away this data. So that will minimize the error in your presentation, in your analysis, further analysis by artificial neural network. Now you can use the artificial neural network to find out whether there is any relation between your monthly salary and body mass index. That's where you are using. But first you have to clean your data.
Yes,
You
sir.
have to know what you are doing. Without
Yes.
knowing, you cannot do anything. It's like a black box. Don't consider AI as the black box tool, which is the panacea, solve every problem in our life. It's not like this.
Okay,
Can
thank
we
you, sir.
sir, you think Gyanjyoti Rauskoil, he says, sir, can you think of very much, okay, that's fine. Can you fit all the mathematical model in and I will like, what kind of I believe technically possible. Yeah, technically you can put all the mathematical model into ANN. People are doing it already. That's why you can see artificial intelligence or ANN is being applied to everywhere, from biology to environmental to physics to astronomical data processing to high energy data processing. Everywhere you are seeing that. Even Physics Nobel Prize citation has given that. In every sphere of life, it is percolating. So that every mathematical yeah, technically, yes. Anything else? I have got a few minutes more. My job is to guide you. I mean, like, to get you going. That's why getting started. It is not like a training session. Training session will be dealt with proper examples and proper worksheets. So it's not a training session. It's just a eye-opener. Like if you have something that I didn't know beforehand, then you should know that. So if you don't know Python, then you should learn Python. If you're really interested in doing artificial neural network or artificial intelligence. Okay, anything else? Dr. Patel, was it okay? I mean, like people could find
Yes,
it.
sir. Yeah, for sure. Yes, sir. We really enjoyed it. Yeah, it remembers our like MSc or PhD days when you used to teach us. So you were as fluent and as brilliant as ever. So we quite enjoyed it.
Thank you. But has it been useful?
Yeah, it's useful, sir. I have learned many things. I hope the participants also, especially from the science background, they have
Yeah.
learned many things from this.
I suggest that you should take a short course, paying
Okay, sir.
2,000 rupees, maybe 2,500. It's very nominal. Yeah, there are
Yes, sir.
plenty of courses around. Which if you take a paid course, this will be nice because that way it can cover quickly in 1 week. Morning
Yeah.
afternoon, morning after. They will give you a practical session and they will tell you like what is the pitfalls. So this is really
Yes.
good. One can take a course.
Yes, sir.
I have taken a course actually.
Okay, sir.
My own thing, because otherwise, how do I learn all these things?
Yes, sir. It's not possible.
It's not possible.
Yeah. Okay.
Sir,
So,
another question from our colleague, Mr. Bijit Bora.
Yeah,
He actually asked that what is the basic difference between artificial neural network and biological neural network?
Oh,
want to know.
Essentially, they are not at all different. They are same. Artificial neural network are actually trying to mimic biological neural network. But biological neural network is much more sophisticated. Our brain is much more sophisticated than the artificial neural network. Only thing is that we cannot do it with speed. We cannot do it with speed. And large number of data sets, then we get confused. We cannot memorize. Our memory is not that strong. So artificial neural network is trying to mimic biological neural network. That's why it's called neural network. They use it the same way. Because, for example, suppose you take a kid, and just like a Tarzan, you take it to the jungle and leave it there. That person, this person will not know anything about it. So what is good or bad, you can judge, but this person cannot judge because he doesn't have a prior training. You need to train. So that's why it's just like, so you remember, I know what is 1 plus 1 is equal to 2. How did I know 1 plus 1 is equal to 2? Because in my mind, I already knew that things, that 1 plus 1 will go to 2, or 2 into 2 will be 4. So I have to be trained. If straightforward, if I'm not trained, if I don't know any mathematics, if you ask me what is 2 into 2, I cannot tell you. So it's like that. That training resides in my memory. That's why you need a computer and a memory and a neural network. All these weights are like biases. For example, you might like red color. You might like a red color with a tinge of orange. I might the red color not with a tinge of orange. These are weights. Your neuron has got a certain weight that you do it that way, but I do it differently. So these are called weights and biases. So every neural network is different. It's like a biological neural network. Only thing is that it is not speedy, it is not effective, but it is much more sophisticated. But we cannot process large amount of data. That is the our. Otherwise, how can I write literary piece? How can Birendra Bhattacharya wrote the Mrityunjay to win Gyanpith Award? It is a neural network. They are doing it. But thing is that you cannot do. He probably took several years to write it. Okay, maybe in future artificial neural network, they will do it in hours. So Trinity Borgohain has one more thing, interesting session. Personally found Google Colab is interesting concept. Yes, Google Colab is very efficient. It's cost effective. You can do research using Google Colab. You don't have to spend a single paisa. That's very important. Okay, Kavindra Goswami, can you please suggest one or two paid courses? Yes, there are many paid courses. Like, yeah, there are many paid courses. I mean, ask Google; they will tell you. Unless because my experience is now 2 years old because we started during COVID. Okay, now you have got better tutor. You can do that. Even Google will be able to tell you. Gemini AI will be able to tell you which is the best course, cost-effective course in India to learn basics of artificial neural network. Artificial neural network is the brain behind artificial intelligence. There are many artificial neurons, like a CNN. CNN is the what is called recurring neural network. There are many things like that. I am only giving you the basics. I only know basics. I think we can call it a day because there's no more questions.
Yes, sir. So, sir, thank you for your nice talk. And we'd like to have a token of appreciation in the digital format. We are going to send it the physical format. So, a small token of love from us.
Sure. It's not necessary,
sir,
but it's okay. Fine. Okay.
So, can you see it, sir? Can you see my screen, Pinky?
Yes.
Okay.
Sir.
Yeah. Sir, your speaker is off. It is muted, I think.
No, I want you can stop my sharing. I don't know how to. If I click, it doesn't say stop sharing.
Okay.
Okay, but anyway, I'm not seeing your screen, by the way.
Oh, okay.
Okay.
You,
But
sir.
Pinky, can you see my screen?
Yeah, we.
Yes,
Maybe I am not. Maybe my setting is. I'm seeing only my screen. I don't know why.
Okay, sir. Probably you need to stop that share. Then,
How do I stop it? I'm not getting any option to stop it.
oh, okay.
Can you stop on my behalf?
Okay. I have stopped. Stop your screen sharing, sir.
Okay, fine. Stop my screen sharing.
Okay.
Now,
Now,
whatever
sir,
you
can you see?
share. Yeah.
Yes, I can see. Right.
Okay.
Okay. Thank you so much.
Okay, sir.
Okay, thank you so much.
thank you very
Thank you
much,
so
sir.
much.
Okay, I can leave now, right?
Yes, sir.
Yes,
Sir.
okay.
Have a
Nice.
nice day, sir.
Yeah, thank you.
So there is an announcement that our next session will start from 2:30. So I would request the participant to be there in the hall, in the meeting box, in by that time. So thank you so much.
One more question was there, but sir has already left.
Oh, okay.
This was asked by Ananta sir.
Uh-huh. Okay. Then probably we should leave the meeting now, and hopefully we can begin by 2:30.
Okay, I request the participants to kindly fill up the feedback form. It is given in the chat box, and I will also
Yeah.
share in the WhatsApp group.